term racked out when applied to breakers refers to the state of the breaker's disconnection from the electrical bus. There are differing interpretations of the term, which can lead to confusion and potential safety hazards. An original understanding of racked out suggests that the breaker is fully disconnected from both the line and load bus, achieved by physically withdrawing it from its compartment. This state implies complete isolation, making it safe to work on the breaker. However, a revised understanding acknowledges that racked out can also mean the breaker is only partially disconnected from the bus. In this scenario, it might remain connected to either the line or load side, which means it is potentially energized and unsafe to handle without proper precautions. The term racked out is ambiguous. It is essential to ascertain the specific degree of disconnection meant in each situation. Failure to do so can result in dangerous consequences, such as electrical shock or arc flash. An incident described in an electrical forensics article illustrates the danger. A breaker was believed to be racked out, but it was only partially disconnected. It closed and energized the bus, causing severe injury to a worker. There are several potential causes for such an incident. Firstly, the breaker may have been racked out only partially, leaving it connected to a side of the bus. Secondly, a malfunction or human error might have caused the breaker to close while partially racked out. Thirdly, proper lockout-tagout procedures might not have been followed, permitting the breaker to be energized when not fully disconnected. To ensure electrical safety, always verify the exact meaning of racked out in the context of the specific equipment being used. Implement appropriate safety precautions before working on any electrical equipment, even if partially disconnected. This verification process should include visually inspecting the breaker's position and using appropriate testing equipment to confirm the absence of voltage. Lockout-tagout procedures are critical. These procedures involve disconnecting the power source, applying a lock to prevent accidental re-energization, and attaching a tag indicating that the equipment is out of service. Only authorized personnel should perform lockout-tagout procedures, and they should be properly trained in the specific procedures for the equipment they are working on. In addition to lockout-tagout procedures, personal protective equipment, commonly referred to as PPE, is essential. PPE can include items such as insulated gloves, safety glasses, and flame-resistant clothing. The type of PPE required depends on the specific hazards present. Regular inspections and maintenance of electrical equipment are also important for safety. These inspections can help identify potential problems before they lead to accidents. Maintenance should be performed by qualified personnel and should follow the manufacturer's recommendations. Training is a cornerstone of electrical safety. Workers should be trained on the hazards of electricity, safe work practices, and the proper use of PPE. Training should be ongoing and should be tailored to the specific tasks that workers perform. Some additional points include ensuring proper grounding of electrical equipment to provide a path for fault current to flow safely to ground, minimizing the risk of electrical shock. Regularly inspect electrical cords and equipment for damage, replacing any damaged items immediately. Avoid overloading electrical circuits, as this can cause overheating and fires. Be aware of the location of electrical panels and emergency shut-off switches. Keep these areas clear and accessible. When working in damp or wet environments, use extra caution and ensure that equipment is properly grounded. Never touch electrical equipment with wet hands. Always assume that electrical equipment is energized until proven otherwise. Use appropriate testing equipment to verify the absence of voltage before working on any equipment. If you are unsure about any aspect of electrical safety, consult with a qualified electrician or safety professional. Staying informed about electrical safety regulations and best practices is crucial. Regulations such as those outlined in the National Electrical Code, commonly referred to as NEC, provide detailed guidelines for safe electrical installations and practices. Understanding and adhering to these regulations can significantly reduce the risk of electrical accidents. For example, the NEC Article 110.16 addresses arc flash hazard warnings, requiring equipment to be marked with warning labels indicating the potential for arc flash hazards. Article 230 covers service entrances, detailing requirements for the safe connection of electrical services to buildings. Article 250 focuses on grounding and bonding, providing requirements for creating a low impedance path for fault current to flow back to the source, reducing the risk of electrical shock and equipment damage. Article 300 outlines general wiring methods, including requirements for the proper installation of conductors, cables, and raceways. Article 310 provides ampacity tables for conductors, specifying the maximum current that conductors can carry safely under various conditions. Article 408 covers switchboards and panel boards, detailing requirements for their construction, installation, and protection. Article 430 addresses motors, motor circuits, and controllers, providing requirements for their safe operation and protection. Article 440 focuses on air conditioning and refrigeration equipment, detailing requirements for their electrical installations. Article 500 through 516 cover hazardous locations, providing requirements for electrical equipment and wiring in areas where flammable gases, vapors, or dust may be present. And Article 700 covers emergency systems, detailing requirements for the installation and operation of emergency power systems such as generators and uninterruptible power supplies. Regularly reviewing and updating your knowledge of the NEC and other relevant standards ensures that you are following the latest safety guidelines. In addition to understanding the NEC, it is also important to be familiar with other relevant standards and regulations, such as those issued by the Occupational Safety and Health Administration, commonly referred to as OSHA, and the National Fire Protection Association, commonly referred to as an FPA. OSHA standards address workplace safety, including electrical safety, while NFPA standards provide guidance on fire prevention and electrical safety. OSHA 29 Code of Federal Regulations, commonly referred to as CFR 1910.301 through 1910.399, cover electrical safety requirements for general industry, providing detailed guidance on topics such as wiring methods, equipment grounding, and lockout-tagout procedures. NFPA 70, the National Electrical Code, provides comprehensive requirements for electrical installations, covering everything from wiring methods to overcurrent protection. NFPA 70E, Standard for Electrical Safety in the Workplace, provides guidance on protecting workers from electrical hazards, including arc flash and electric shock. NFPA 79, Electrical Standard for Industrial Machinery, provides requirements for the electrical design and construction of industrial machinery. IEE 1584, Guide for Performing Arc Flash Hazard Calculations, provides guidance on calculating arc flash hazards and selecting appropriate personal protective equipment. By staying informed about these standards and regulations, you can ensure that you are following the latest best practices for electrical safety. Furthermore, consider the importance of conducting regular risk assessments to identify potential electrical hazards in the workplace. A risk assessment involves systematically evaluating the likelihood and severity of potential hazards, allowing you to prioritize safety measures and allocate resources effectively. Risk assessment should be conducted by qualified personnel who are familiar with electrical safety principles and the specific equipment and processes being evaluated. The assessment should identify potential hazards, evaluate the likelihood and severity of each hazard, and recommend appropriate control measures to mitigate the risks. Control measures may include engineering controls, such as installing arc flash barriers or upgrading equipment to improve safety, administrative controls, such as implementing safe work procedures or providing additional training, and personal protective equipment, such as providing workers with arc-rated clothing or insulated gloves. It is important to review and update risk assessments regularly to ensure that they remain relevant and effective. Changes in equipment, processes, or regulations may require adjustments to the risk assessment and control measures. It is important to remember that electrical safety is everyone's responsibility. By following safe work practices, using appropriate PPE, and staying informed about electrical hazards, you can help prevent accidents and create a safer work environment. When in doubt, always consult with a qualified electrician or safety professional to ensure that you are following the proper procedures. Electrical safety is not just a set of rules, it is a mindset that should be ingrained in every worker's daily routine. By prioritizing safety, you can protect yourself and your colleagues from the hazards of electricity. The key takeaway is to always verify the exact meaning of RACT art in the specific context and ensure that the appropriate safety precautions are taken before working on any electrical equipment, even if it is partially disconnected. This includes following lockout-tagout procedures, wearing appropriate personal protective equipment, and conducting regular inspections and maintenance of electrical equipment. Furthermore, continuous training and education are essential to ensure that workers are aware of the latest safety regulations and best practices. Electrical safety is a shared responsibility, and by working together, we can create a safer work environment for everyone. Remember to treat every electrical circuit with respect and never take shortcuts when it comes to safety. A moment of carelessness can have devastating consequences. Stay vigilant, stay informed, and stay safe. Some additional points to remember are to avoid working on energized equipment whenever possible. To energize the equipment and follow lockout-tagout procedures before starting any work. Use insulated tools when working near energized equipment to prevent electrical shock. Maintain a safe working distance from energized equipment to avoid accidental contact. Be aware of the potential for arc flash and take appropriate precautions, such as wearing arc-rated clothing and using arc flash barriers. Never remove or bypass safety devices, such as guards or interlocks. Report any electrical hazards or unsafe conditions to your supervisor or safety manager immediately. Participate in safety training programs and stay up to date on the latest safety regulations and best practices. Encourage your colleagues to follow safe work practices and report any potential hazards. By working together, we can create a culture of safety that protects everyone from the hazards of electricity. Electrical safety is not just a matter of compliance, it is a matter of life and death. Take it seriously and make it a priority in everything you do. And remember, electricity is a powerful force that can cause serious injury or death if not handled properly. Always respect electricity and follow safe work practices to protect yourself and others.